All right, I'm going to pick up on problem number 6A from the review for Chapter 12 of Lehmann's book. This is for Math 120 at Kenyatta College in the fall of 2015. So what I'm looking at here is problem number 6A, which is solving a rational equation. And what I'm doing is I'm in the process of clearing the equation of fractions. So I had found my restrictions to start, so I didn't forget to do that later. I had found the least common denominator by looking across here at all the denominators and saying I see 2's and I see an x minus 4. X minus 4 is to the first power, so my least common denominator was 2 times x minus 4. And I had gotten to the point where I was going to multiply every single term by my 2 times x minus 4. And now I'm going to cancel. I do not multiply out, I cancel. So that one goes with that one, and that leaves me with x times x minus 4. And then in my next one, I get to cancel the x minus 4's. So that leaves me with minus 2 times x. Then that equals the x minus 4's cancel, and that leaves me with negative 4 times 2, which is negative 8. Now I want to go ahead and distribute out here. So this is going to give me x squared minus 4x minus 2x, and because I notice that this is squared, I know that this is a quadratic equation, and quadratic equations must get solved with the zero factor property. So I'm going to go ahead and bring the 8 over here because that puts it in standard form, so I can go ahead and get the zero factor property. So this is plus 8, and that's equal to 0. So this is x squared minus 6x plus 8. So I need the factors of 8 that are going to sum to 6. Well, that's easy. That's the first thing that comes to mind is 4 and 2, right? 4 times 2 is 8, and the sum of 4 and 2 is 6. So I'm going to need a 4 with an x with a 4 and an x with a 2. Now once I get that, then I have to deal with signs. So my signs have to be the same because it's a sum, and the sign must be negative to go along with that middle term, because the only way I can get a negative if I add is if I add two negatives when I'm multiplying and getting a positive. So now once I have this, I'm going to solve each of these simple linear equations using the zero factor property, in other words. And so I have x minus 4 equals 0 and x minus 2 equals 0. So this is plus 4 and plus 4 over here. And now I have x is equal to 4. And then over here, plus 2 and plus 2. And then that gives me that x is equal to 2. At this point, what I don't want to forget to do is check those restrictions. So I'm going to take a look here, and I'm going to look up here. And when I see this, uh-oh, that's trouble. That means that's not a solution at all. So that's where the restrictions come in. 2 should be fine, and so this is my only solution. All right, moving along. I'm going to again start by factoring these denominators so I can find out what my least common denominator is. Z squared minus 16 is a binomial. It's a difference. Z squared is a perfect square. 16 is a perfect square. So this is the difference of two perfect squares, which we'll factor as conjugates. So I need the roots of those two perfect squares. So I have a z and a 4 as my roots. And then I have the sum of those and the difference of those, and that's how it'll factor. Now I look at my restrictions before I get too involved in this. So my restrictions, because a z plus 4 and a z minus 4 can't be equal to, oops, I just wrote x, because a z minus 4 and a z plus 4 can't be equal to 0. That's the two things that are in the denominators. So there's one of them. And there's the other one, and that doesn't equal 0 either. So from this one, I will get a minus 4, and from this one, I'll get a plus 4. So z, as it turns out, can't be equal to either a positive or a negative 4. So now I'm going to go ahead and I'm going to find my least common denominator, which is z plus 4s and z minus 4s. And when I take a look at all of those z plus 4 and z minus 4s powers, I see they're all to the first power, so that means that's simply my LCD. So z plus 4 and z minus 4 are going to get multiplied by each and every one of my terms, because remember, my job here is to clear the equation of fractions, not build higher terms. I do not want higher terms. I just want to clear this equation of fractions. And I can do that by using the multiplication property of equality and canceling and then multiplying out. So there we go for each of those, z plus 4, z minus 4. Z plus 4 cancels with z plus 4, z minus 4 cancels with z minus 4, which leaves me with this crazy z squared plus 16. Remember, z squared plus 16 does not factor. That's the sum of squares, and sum of squares do not factor. My next one, the z plus 4, will cancel with the z plus 4, and that's going to leave me with a z times a z minus 4. So that's my next set. Now the last one, the z minus 4 is going to cancel with the z minus 4, and that's going to leave me a minus 4 times z plus 4. Now the next step I need to do is expand out this right-hand side so I can see what I have. So I'll distribute here and here. So now I have a z squared plus 16, and that's equal to z squared minus 4z, and then I'm going to distribute the negative 4 through here, so negative 4z, and then a negative and a positive make a negative, and that's a 16. So now I'm going to take a look and I'm going to go, oh, well, you know what, I have a z squared on each side, so if I subtract this, right, from both sides, the z squareds are really going to go away. So this is not actually a quadratic equation. Even though I see a z squared, the z squareds go away. So what this says to me is that this is actually a case of a linear equation. So I'm going to simplify this. So I'm going to do something that I only do in more advanced classes here. I'm going to go ahead and I'm going to do two things at once. So I'm going to move the constant over to this side by adding 16, so that's going to give me 32 is equal to, and I have a negative 4 and a negative 4, which is a negative 8z. Now I get to divide by the negative 8z to find out that z is equal to a negative 4. Uh-oh, look what happened. That is a restricted value. So in this case, because this is not allowed to be a solution, there actually is no solution for this rational equation. So we have seen a case where one of the solutions went away and one stayed, and now we've seen that the only solution we got was not a valid solution at all. All right, moving on to our next problem, problem number 7. We're solving for a variable. So this variable is in multiple places. So the first thing that I'm going to do is I'm going to apply a little bit of proportion knowledge here. So I'm going to say that this is over 1, and I'm going to do the cross products are equal. So A times C plus D is equal to A minus C. Now I'm going to do the distributive property here because I want to get the C's as unique terms. So I have AC plus AD is equal to A minus C. Now these two C's that you see here and here are my focus. They're my X's, so to speak. So they have to get together and everything else can go away from them. So I'm going to add C to this side, and I'm going to take a look at that. So now this is going to look like AC plus C. And I'm just going to put some parentheses around that so that you see it. And then plus AD equals A. Put some color in here for the C's. So there's my C's. And there's my C's. And now I need to move the AD over there because that's not like the C terms, so it's just a number. So I have A and C plus C, and that's equal to A minus AD. Now I can't add those, remember, but I can take a look at this. So what the next thing that I want to do, put some more color in for the C's, is I want to get one single C. Well, the C's are a GCF over here, so I'm going to factor that C out, and that's going to leave me with A plus 1. And then that leaves me with A minus A over D, and this I'm going to divide by A plus 1 and A plus 1. And so my answer up here is that C is equal to A minus AD over A plus 1. Now, because that denominator is a binomial, there's nothing simpler that can happen here. And remember, there's no canceling in addition, so that's as good as it gets. And that's my final answer. Now, moving on to my next one, we have a proportion here. So we're going to find the value of x. I've already drawn this out with all of these instructions in here. So I have my two triangles, and my BC is 2x minus 5 feet, and my AC from here to here is 45, and the EF is 7, and my AF is 2x plus 1. So I want to use my knowledge of similar triangles to solve this. So the similar triangles, the sides that are across from equal angles are equivalent to or proportional to one another. So this angle here and this angle here, because of parallel lines cut by a transversal, those are corresponding angles and therefore equal. So this side here is proportional to this side here. So we have AF is proportional to AC, and I'm setting up the small triangle to be proportional to the big triangle, and I like to note all these things. Now also, these two sides over here, these share an angle, so this angle here shows me that these two are proportional. So the small triangle is EF, and the larger triangle is BC. So those are my proportionalities. So this is going to lead to 2x plus 1 over 45 is 2, and then the EF is 7, is to 2x minus 5. So now we're going to use proportions. Cross products are equal, so cross products are equal. So I have 2x plus 1 times 2x minus 5. And then I have 45 times 7. So we have 4x squared, and then I have minus 10, and I have plus 2. So that's going to give me minus 8x, and then 5 times negative 5 times 1. And then we are going to subtract this value over here. And let's see, that's 5, carry the 3, 28, that's 315. So we're going to subtract 315 because I can see that this is a quadratic, right? So I'm going to go ahead and put it in standard form. So now I have 4x squared minus 8x, and then minus 320. And so what I'm going to notice here is there's a GCF of 4 in here. This is divisible by 4 as well. So I'm going to take out that GCF of 4, giving me x squared minus 2x, and then minus 4 will go into 32, 8, so that's an 80, and then that's 0. And then I need the factors of 80 that give me a difference of 2. So 8 times 10 are the two that come to mind, and they do multiply to 80, and they do give me a difference of 10. So 4 times x, and then minus 10 because it's a negative difference, and x, and plus 8. Now because these are going to be set equals 0, this one is going to give me an extraneous solution because it's going to give me x is equal to -8. And setting this one equal to a 0, I'm going to get x is equal to 10. So here is my x value. So x is equal to 10. And then putting this into BC, I have 2 times 10 minus 5, or 20 minus 5, which is 15. And then I have to look at units, which they were feet. So this is 15 feet, and there's my solution. Now moving on to the last one here. This last problem, I've written it all down here, but here's the thing. According to Hooke's law, the force needed to stretch a spring is directly proportional. That was left out over there. The directly proportional to the amount of the spring is stretched. So we have force, I'm going to call force F, and then I'm going to stretch the string, and I'm going to call this S for stretch of string, and that's directly proportional, and that's what we need for a proportional setup, a variation setup, not proportionality. So we have the force is 50 pounds, and this is going to give us K times the spring getting stretched 5 inches. So we have this is divided by 5, and that's going to be used to solve for K, our constant of proportionality. So K is equal to 10. So this is 10, and this is pounds, and that's per inch. So the string stretches that amount of pounds with every inch. And so the next thing that I'm going to do is I'm going to say that this then yields an equation. And so I have 10 and then S. So now I have an equation to put this second thing into. So if I have 120 pounds of force, then 10 times the S is going to tell me how much the spring stretches. So I'll divide both of these by 10, and that will cancel, and so that tells me the spring stretches 12 inches, and that completes these exercises.